Right. Okay. So, good afternoon, dear students. So, in the previous lecture, hello, please unmute yourself. All are instructed to unmute yourself. Okay, fine. So, in the previous class, we have discussed this belt friction and this very important relationship. Okay. So, what you have to remember regarding this particular relationship, this ratio is what? It is this ratio is the tension in tight side to the tension in slack side, and that is equal to e to the power mu s into beta. Okay. So, in the previous class, we have discussed. Okay, fine. I explained this particular problem number 7 in the previous class. Now, what I suggest, better I will take this particular problem along with this equilibrium chapter. Okay, because here we are going to, or we need to draw the free body diagram of this particular lever. Now, how to draw the free body diagram of this particular lever, that you will better understand after knowing this equilibrium chapter, because in equilibrium chapter the first step is to draw the free body diagram. Okay, and then after drawing the free body diagram, then you apply the conditions of equilibrium, that is summation fx is equal to 0, then summation fy is equal to 0, and then summation moment is equal to 0. Okay, so these three conditions we are going to apply to this particular free body diagram, and then we can find out the unknown reactions or unknown forces by applying these three equations. Okay, so these three equations are called as fx0, fy0, and moment 0. These three equations are called as the conditions of equilibrium. Right? Okay, fine. So let us start. Okay, the unit number 3. The title of this unit number 3 is equilibrium. Right? And these are the contents of this unit 3, that is equilibrium. So the first part is free body diagram, the concept of free body diagram, then equilibrium of concurrent parallel forces in a plane, equilibrium of general forces in a plane, then equilibrium of three forces in a plane, then types of beams, simple and compound beams. Okay, types of supports and reactions. And this is the second part, forces in space, resultant of concurrent and parallel forces in a space, then equilibrium of concurrent and parallel forces in a space. Okay, fine. So these are the contents. So already we have discussed this particular slide number 9 before the starting of the friction unit, right? Equilibrium of a particle. So already we know that a body or a particle is said to be in equilibrium if the resultant of the forces acting on it is equal to 0. Okay, so already we know this particular fact, right? Now for the concurrent force system in general, we have these two equations available. One is summation fx is equal to 0, and the second one is summation fy is equal to 0. Okay, now for concurrent force system, what I can say in general, summation moment is not applicable. Summation moment is equal to is not applicable, because in concurrent force system what is happening, all the forces are passing through the common point. Okay, all the forces are passing through some common point, right? Say suppose through this point O, and hence that is why the summation moment is equal to 0 condition is not applicable for the concurrent force system. Maybe it may be coplanar or it may be in space, right? So for concurrent force system, only these two equations we are going to apply, that is summation fx is equal to 0 and summation fy is equal to 0. Okay, right. So already we have discussed this particular point, that is equilibrium of two forces. Just let me revise quickly. If a particle is acted upon by some background noise is coming. Even after warning many times, if the students are not muting themselves, then seriously I must have to take action. Seriously, I must have to take then action. A strict action will be taken against such students. If after repeated warning, if students are not muting themselves, okay, fine. Right, coming back to this discussion. So equilibrium of two forces. Equilibrium of two forces. If a particle is acted upon by the two forces, and if that particle is in equilibrium, then these two forces must be equal, opposite, and collinear, no doubt. So that means if suppose this is a body which is acted upon by the two forces F1 and F2, and if this body is in equilibrium, as we know, when a body is said to be equilibrium, when the resultant force is equal to 0, right? So this is the body which is acted upon only by two forces, and if the resultant is equal to 0, so then no doubt these two forces must be equal, opposite, and collinear. Collinear means what? Having same line of action, and acting in opposite direction. Okay, right? Same line of action. That is what is called as collinear force system. Okay, so in short here F1 is equal to F2, correct? Also we have discussed the equilibrium of three coplanar forces. If say suppose this is the point O which is acted upon by these three forces F1, F2, F3, right? Just I'm revising, already we know this fact. Also we have solved the numerical problem using this particular what we can say the sine rule, right? So this is the point O which is acted upon by these three forces F1, F2, F3, and let these are the angles θ1, θ2, θ3, etc. Okay, we know the meanings of all these things.
Hello, sir.
Yes, please.
Sir,
yes.
slide is not visible.
Not visible?
Slide is not visible.
Okay, please wait. Please wait.
It is visible, sir. It is visible, sir.
It is visible?
Visible, sir.
Yes,
Visible,
sir.
sir.
Visible, sir.
Okay, then you might be having some network issue. Please check. Please check at your end. Is it okay now? Shall I continue?
No, sir.
Yes, sir. Yes, sir. Continue. It's
Yes,
visible.
Yes, sir.
Okay, fine.
Yes, sir. Continue.
Yeah, just wait. Once again, let me share the slides. If someone is having issue. Now just please let me know. Yes, is it visible? Please give
Yes,
me
sir.
Okay, fine. Okay.
Yes, sir. It is visible.
Yeah, fine. So now, okay, fine. So this is the point. I mean, this is the body which is acted upon by these three forces F1, F2, F3, and if that body is in equilibrium, and if I construct a polygon as shown in this figure, of course, here no doubt, as the resultant R is equal to 0, and hence I must get a closed polygon. Okay, that means the start point and the end point must coincide with each other, right? And then by applying the sine rule, we got this very important formula F1 upon sine of θ1, where θ1 is the angle between F1 and F3, and θ2 is the angle between F1 and F3, right? I mean, in short, so this F1 upon, I mean, the force divided by sine of the angle between the other two forces. Okay, even this problem you may solve by applying these two equations also. That means summation fx is equal to 0 and summation fy is equal to 0. So these are what I can say the general equations. Okay, if a body is acted upon by maybe some n number of coplanar concurrent force system, 1, 2, 3, 4, 5, and so on coplanar concurrent force system, and to solve the unknowns, you can in general apply these two equations fx0 and fy0. So ultimately we are having two equilibrium equations, so we can solve for maximum two unknowns. Please note that, right? So from this discussion we can conclude that if a body is acted upon by three coplanar forces, and if that body is in equilibrium, then these three forces must be concurrent. This is a very, very important conclusion, right? Then equilibrium of more than three forces. Okay, so if a body is acted upon by the three forces, more than three forces, just now I told you here, coplanar concurrent force system, then we are going to apply summation fx is equal to 0 and summation fy is equal to 0. Now, if say suppose let us consider this particular example, which already we have discussed, a ladder which was resting against the wall and the floor, something like this, correct? And then what we did, and this particular force system is a coplanar non-concurrent, right? Coplanar and non-concurrent. Non-concurrent means not meeting at all the points, right? So this particular ladder is acted upon by how many forces? This F, then N1, then self weight, and then N2. Okay, and they are not meeting at some common point. So this is a coplanar non-concurrent force system. So as far as this coplanar non-concurrent force system is concerned, in general, we have these three equations available to solve for the unknowns. That means summation fx is equal to 0, then summation fy is equal to 0, and summation moment is equal to 0. So most of the time in this particular unit, and I mean in this equilibrium unit, we are going to apply these three equations of equilibrium, fx0, fy0, and moment 0, and then we are going to solve for the unknowns. Before that, we need to draw the free body diagram. Okay, so drawing the free body diagram is a very, very, very important step as far as the equilibrium is concerned, right? So let us discuss about how to draw the free body diagram. Okay, so as I already defined what is meant by free body diagram, so it is an isolated diagram showing all the external forces acting on it, right? And we have solved this particular problem, I mean ladder problem, in unit number 2 while discussing friction, correct? So there we draw the free body diagram. We replaced this wall, smooth wall, by its reaction. Okay, and then also we replace this floor, rough floor, by its reaction. And there were two reactions. One is this normal reaction, and the second one is the frictional force, right? And another force is its self weight, right? So in this particular unit, we are going to discuss in detail how to draw the free body diagram step by step, right? So before, I will take one simple problem to understand how to draw the free body diagram. Okay, so through this problem, I will explain you how to draw the free body diagram. Okay, so let us discuss this problem number 1 as far as this unit number 3 is concerned. Just go through this problem. Two smooth spheres of radius r is equal to 130 millimeter. So this is sphere A, whose radius is 130 millimeter, and this is sphere B. Its radius is also same 130 millimeter, and weight 100 Newton each. So weight of sphere A and sphere B is same, which is 100 Newton. So their radius and weight both are same for both the spheres. So rest in an open channel. So this is an open channel, something like this, rectangular open channel with smooth base and smooth vertical sides. Smooth base, please note that. So this is the smooth base and smooth vertical sides. So the width of the channel being 500 millimeter. This is the width of the channel which is given in the problem. Now find the reactions at C. This one here at this point of contact C, then D here, and then at E. Okay. Yes. So the question is to find the reactions at C, then D, and then E. So step by step we are going to solve this problem. So first, in order to solve the reactions at all these points of contact C, D, E, first of all, we will consider the FBD of the cylinder A. Okay, so this is the cylinder A. Now, what are the various forces acting on the cylinder A? So please note that all the contact surfaces are perfectly smooth. This is given in the problem, right? So the various forces acting on the cylinder A are, first of all, is its self weight. which is WA, that is 100 Newton, correct? So please note that how we define the free body diagram. It is an isolated diagram showing all the external forces acting on it. External forces. So isolate means what? You remove all other connected bodies by their reaction. So that means what? Here I am going to remove this vertical wall of the channel by its reaction. So here this is a vertical wall, and of course it is a smooth vertical wall. So here there is one reaction RC which is perpendicular to the vertical wall. Okay, so please note that. So means RC is in horizontally rightward direction, right? Next one, which is the body which is in contact with body A, as we are drawing FBD of A. So here there must be reaction offered by this cylinder B onto A. Okay, so this is what, say, this I am terming this as RB. Okay, any other external force acting on A? No, that's all. Okay, so these are the three forces. That means self weight, it's self weight 100 Newton, then reaction RC offered by this vertical wall, and reaction offered by B on A. So this is RB. So this is this cylinder A is acted upon by these three forces WA, RC, and RB. And as I told you, and of course here we know that this cylinder, all this cylinder A, cylinder B, both are in static equilibrium. Please note that they are at rest. They are at rest, complete rest. Okay. Okay. So as I told you here, this is a very important conclusion. See here, if a body is acted upon by three coplanar forces, and if that body is in equilibrium, then these three forces must be concurrent. Okay, so here this particular body A is acted upon by the three forces, right? So if I consider, say, this as a point A, its center of gravity as a point A, then this point A is acted upon by these three forces. Now see how I am showing all these three forces acting away from the point of concurrent. See, the body A is in equilibrium and this is acted upon by three forces. So no doubt all these three forces must pass through some its center of gravity because the weight is acting through its center of gravity. Please note that. And here it is clear that this RC is in horizontal direction, correct? So as far as this vertical wall is concerned, this vertical wall is the tangent at point C, correct? Tangent at point C to this circle, and hence RC must be perpendicular to the tangent, and hence no doubt RC must pass through its center of gravity, or say the center A, center of the circle, correct? Right. Now one more. Now here if I draw what I can say, draw the tangent at the point of contact, okay, and this RB is normal to the point of contact. Okay, so this point of contact is the tangent here at this particular location, right? And this RB is normal to the tangent, and hence no doubt it must pass through its center of this particular circle A, right? So all these three forces are passing through the center of gravity, and then what I'm doing here, in order to apply this what I can say, the sign rule, I told you, as I already told you, we must show all the forces acting away from the point of concurrent, and then you find these angles theta 1, theta 2, and theta 3, right? So the same thing we are going to do now. Okay, so I'm showing all these three forces acting away from the point of concurrent. So I have shown RC acting away from point A, then WA acting away from point A, right? And then this RB acting away from point A, something like this. Okay, so as far as, okay, now it is very, as the radius of this circle is given, the base width of the channel is given, and hence very quickly we can find out these angles. How to find these angles? Okay, that I will explain you on the next slide, right? So now once I know these angles, Now see, total how many unknowns are there? WA is known, it is 100 Newton, correct? 100 Newton. So how many unknowns are there? RC and RB. Okay. So by applying the sine rule, we can find out these two unknowns, or even you may apply these two conditions of equilibrium, that is summation fx is equal to 0. You develop one equation, then by applying summation fy is equal to 0, you develop another equation, and then you solve these two equations simultaneously to get the values of RC and RB. Okay, or the other ways, as the body is acted upon by three forces and that body is in equilibrium, so you may go for this particular sine rule F1 upon sine 1, etc. Okay, so by applying sine rule, you will get the answer very quickly within maybe 1 or 2 steps. Okay, fine. So here the calculations have been done how to calculate this angle between the two forces. Okay, so this is done here. Fine. Now see here, as far as this cylinder A is concerned, as we know, the radius of the cylinder A is 130 millimeter. Radius of cylinder B is also 130 millimeter. It is shown here. The base width of the channel is given. It is 500 millimeter. Okay. Now, so AC is A to C is 130 millimeter. B to D is 130 millimeter, and hence what should be this distance FB? No doubt it must be 500 minus 130 minus 130, which is 240 millimeter. So we know the horizontal distance between this F and B. Correct? Right? Now, what should be the distance AB? It must be 130. This is 130 plus 130. That means 260 millimeter. Right? Okay, so as far as this right angle triangle AFB is concerned, what we know here? We know the diagonal AB, which is 260 millimeter. Also, we know this FB, which is 240 millimeter, right? And hence, very quickly we can find out this angle B. Correct? Yes. Right? Okay, it very simple calculation. Correct. Fine. That means what here this 240 is equal to 260 into cos of this. If I consider this as a theta, angle B as a theta. Okay, right. So cos of theta is equal to theta is equal to cos inverse of 24 divided by 26. Correct. Right, and hence we can compute the value of theta. So theta is 22.62 degree, right? And this, as I already told you, fine. This why in this particular slide number 13, I have explained you how to draw the free body diagram of cylinder A. Correct. So here this RB is directed along line AB. Please note that I have already explained you. Correct. So this is for the line of action of this RB, where what is RB? RB is the reaction offered by B onto the cylinder A. Okay, so this is the free body diagram of cylinder A, which I already explained you. Then what I did here, I have drawn all these three forces acting away from the point of concurrent. So all these three forces are meeting at point A. Okay, something like this. Okay, and then I have drawn this particular figure. Okay, here I have. When we are going to apply this sine rule, in that case we must show all the forces acting away from the point of concurrent. Again, I'm repeating this point, it's very important, right? Fine. Okay, then now you find out these angles. So here we know the angle made by RB with respect to horizontal, which is 22.62, right? And hence what should be this angle between RB and W? It will be this 90 plus 22.62, which is 112.62, right? Then here already we know this angle made by RB with respect to horizontal, it is 22.62, and hence this angle between RC and RB is 180 minus 22.62, which is 157.38. Already we know this is 90-degree angle. Correct. So applying this sine rule, this 100 divided by sine of the angle between other two forces, that means RB and RC, which is 157.38. Okay, then RB, this RB divided by sine of the angle between other two forces RC and WA, which is 90. Then RC divided by sine of the angle between other two forces, that is RB and WA, which is 112.62. Right. So after solving, we got RB as 260 Newton and RC as 240 Newton. Okay. So here we have found out one answer, that is reaction at C. Okay. So that is RC is equal to this much. Of course, it is in leftward direction. Right. Now, what is the use? Sorry, yeah, this is RC, right? Yeah, RC is 240 Newton rightward, right? Now, what is the use of this RB? Why we have calculated RB? Yeah, while explaining in the this wedge friction. Now, what we are going to do in order to know the reactions at D on cylinder B and reaction at E on cylinder B, we are going to draw the free body diagram of this cylinder B. Okay, now what are the various forces acting on cylinder B? Of course, the first one is the self weight, which is say WB. Then reaction offered by this vertical wall, which is RD, right? So as okay, so this RD is perpendicular to this what I can say, this vertical wall. Okay, and hence RD is in horizontally leftward direction. Okay, next reaction offered by this horizontal floor at E, which must be no doubt say RE vertically upward direction. What next? Any other reaction? Any other force, external force acting on
Reaction by
RB.
very good,
reaction
very
by
good, excellent answer.
Ray.
Reaction offered by A on B. Okay, so in the previous step, see here, I mean, when we considered FBD of A, there we have shown RB, where what is RB? RB is the reaction offered by B on A. And while drawing FBD of B, we are going to show the reaction offered by A on B. So can anybody answer? Can anybody answer what is the relationship between reaction offered by A on B and B on A?
RB is equal to minus of RA.
Correct, they are equal and opposite, and this is as per Newton's third law of motion. To every action there is equal and opposite reaction. Okay, so if I represent this as say RA is the reaction offered by A on B, and if I represent this as say suppose RB, which has a reaction offered by B on A, no doubt they must be equal, opposite and collinear. Very important conclusion. Okay, very important conclusion, right? So here now when we draw free body diagram of the cylinder B, then I must have to show the reaction offered by A onto the block B. Okay, which is okay, the calculations have been done in detail in the next slide here. Okay, fine. So before that, one very important point, let me tell you that. So suppose sometimes now what it requires to consider, FBD of both the bodies together, something like this. So now here I am say suppose now in this problem it is not required, but in some of the problems it is required to consider FBD of both the bodies together. Now here I am going to draw FBD of A and B together. Now what are the various forces, external forces acting on it? Of course, the first one is the weight on A, weight on B. Okay, then what next? We are replacing this vertical wall by its reaction, and hence there must be the reaction offered by the wall onto block A, say that is RC. Then here the reaction offered by this vertical wall at D, and this is RD. Okay, and what next? The reaction offered by this horizontal floor at E, and this is RE. Okay. Now, what about reaction offered by A on B and B on A? Whether I need to show here. So suppose this is RA. RA is the reaction offered by A on B, and this is RB, which is the reaction offered by B on A. Whether is it an external force? Is it an external force? Because see, what is FBD?
No, sir.
How, see here how FBD is defined as? It is an isolated diagram showing all the
External forces.
External forces acting on it. So now, as far as now, see here, we are drawing FBD of both the bodies together. So that means only we have replaced these two vertical walls and this horizontal floor by their reactions. So that means what here, this RA and RB, as we know that as per the Newton's third law of motion, RA and RB, they are equal, opposite and collinear, and hence they get cancelled. So that means what, they becomes an internal force. Okay, they becomes an internal force. So as for on FBD, we are not going to show any internal force, only we are going to show external forces acting on the body. That's very, very important conclusion. Okay, right. So while drawing FBD, only we are going to show external forces acting on the body. No need to show the internal forces. The internal forces, they are equal, opposite and collinear, and hence gets cancelled. So no need to show, for example, here the reaction offered by A on B and B on A when we are considering FBD of both the bodies together. Very important. I hope you have understood this particular concept. Okay, fine. Now let us find out this thing. Support reaction at D and E. To draw the support reaction, to know the support reaction at of block B, cylinder B. Okay, as I already explained you how to draw the free body diagram of block B. Okay, and hence it is shown here. Okay, so these are the various forces. So as here I have mentioned, RA is equal to RB is equal to 260 Newton. Okay, so reaction offered by B on A and A on B, they are equal and opposite and collinear, right? So magnitude is same, 260 Newton, but in opposite direction. Okay, angle is same, 22.62 degree, same angle, 22 point, yeah, this thing RB, 22.62 degree. Now this body is acted upon by four forces. What are the four forces? WB, then this 260 Newton, then RD and RE, and hence we cannot apply this what I can say, this sign rule. Sign rule is applicable only and only when the body is acted upon by three coplanar concurrent forces, and if that body is in equilibrium. Okay, very important. So here better, now here we are going to apply, as I already mentioned, we are going to apply two equations, fx0 and fy0. Okay, so resolve all the forces along x-axis and y-axis. Okay, our usual sign convention, that means rightward positive and upward positive, right? So this is the sign convention I am going to choose. So rightward is positive, and hence applying summation fx is equal to 0. So there will be x component of this 260 Newton force with plus sign. I mean its x component will be rightward. So 260 into cos of 22.62. Okay, and then RD is in negative x direction, so minus RD, and then we got RD as 240 Newton in leftward direction. Okay, then apply summation Fy is equal to 0. So then this minus 100, as we are considering the upward as positive, so weight is downward, so minus 100. Then y component of this 260 Newton force is 260 into sine of 22.62 with negative sign. Okay, and then this plus RE. Very simple. Okay, after solving, we got RE as 200 Newton in upward direction. Correct. Now, if you here we have got the all the external reactions. Okay, So now as far as now, if I see here, we have got RE, correct? RE, yeah, how much is RE we got? RE as 200 Newton upward, RE 200 Newton in upward direction. Already I have shown the direction. Then how much is RD we got? So this is RD. RD is equal to 240 Newton, correct? 240 Newton leftward, right? And then RC, how much RC we got? RC is 240 Newton leftward. 240 Newton leftward. Now, as far as the whole system is concerned, please note that the entire system is concerned. For the entire system also, because we know that the entire system is in equilibrium, and hence its any individual body must also be in equilibrium. Okay, so what we did, by applying conditions of equilibrium to the individual body, body A first and then body B, we have found out this support, I mean this reaction at, I mean RC, RD and RE. Now, when I consider the FBD of this entire body, I mean both the bodies A and B, and if I show the support reactions RC, RD and RE, then I must get summation Fx is equal to 0 as well as summation Fy is equal to 0. So this is the check what I can say. Now check whether summation Fx is equal to 0 or not here. See here, this is leftward,
Yes, sir.
rightward 240 Newton force and leftward 240 Newton force, correct? And then they gets cancelled. Similarly, what about summation Fy? Just check whether summation Fy is equal to 0 or not. So we know here WA is 100 Newton, WB is also 100 Newton. So these are downward. So downward, total downward force is 100 plus 100, 200. And total upward force is 200 Newton force. And they gets cancelled. Alright. Total downward force 200, total upward force is 200. Got my point? Yes or no? Okay. So this is very important. What I can say, problem from viewpoint of what I can say, drawing the free body diagram and applying the conditions of equilibrium when there are 3 forces and when there are 4 forces, right? So now let me go back to this particular band break problem, which I discussed yesterday. Only I introduced this problem. Okay. So this problem is a combination of both friction and then this equilibrium. Okay. Yeah, please go through the problem. A band belt is used to control the speed of a flywheel as shown in this figure. Okay, yesterday I told you, so this is a flywheel basically. This circular one is a drum which is rotating in which direction it is given? Rotating in clockwise direction. So this is the direction of rotation, omega, say suppose. So what I can say, before applying the brakes onto this rotating wheel, the wheel was rotating with constant angular velocity omega. Okay, fine. So a band belt, so this is the belt which is wrapped for this particular flywheel as shown in this figure. A band belt is used to control the speed of a flywheel as shown in the figure. Determine the magnitude of the couple being applied to the flywheel, knowing that the coefficient of kinetic friction between the belt and the flywheel is 0.25. Now, why it is given kinetic friction? Because the wheel is in motion while belt is at rest. Please note that. So wheel is in motion. So we have to use the coefficient of kinetic friction, right? So it is not an impending motion case. In case of impending motion case, mu will be mu s. And when there is this motion, when there is motion, then in that case we are going to use the value of mu k. Okay, and same relation, that means I mean T2 by T1 is equal to e to the power mu k into beta. Okay, only the thing is that we are replacing mu s by mu k, that's all. Calculation is same. Fine. So determine the magnitude of the couple being applied to the flywheel, knowing that the coefficient of kinetic friction between the belt and the flywheel is 0.25 and that the flywheel is rotating clockwise at a constant speed. Okay, so here first of all what we are going to do, okay, let me here. So first of all we will draw the free body diagram of this one, I mean this flywheel. Okay, so this flywheel is supported here. So this is the hinge. Now what is meant by hinge? Okay, that I'm going to explain you, because our next point is this thing regarding as far as drawing the free body diagram. This discussion is very important. Reactions and support, reactions are the supports and connections. Okay, so this table, this table 1, this table 2 and table 3 are very important from viewpoint of drawing the free body diagram. Okay, so as far as this, okay, here let me discuss about this frictionless pin or hinge. Okay, so because there is a frictionless pin or the hinge. So frictionless pin means what? See, this is a, say suppose a rod which is pinned at what I can say at this particular, say, location A. So all of you are familiar with the hinge. Hinge means what? Say we know the door hinges. Okay, so about hinge, say suppose if I apply a force to this particular rod, then what will happen? It may rotate something like this, but it, I mean, the position of point A will not change. It will not, point A will not displace from this point A to some other point A. It can rotate just like a door. If I apply a force to the door, then what happens? The door revolves about the hinge. Okay, so this is a frictionless pin or a hinge. So at the frictionless pin or the hinge, what happens here? So this is very similar to the rough surface as what we discussed in case of this ladder friction. Yeah, here ladder friction case. Okay, so this point is a what I can say, the support with a friction. Okay, so in case of support with friction, or in case of rough surface, there will be one normal reaction, and of course there will be the friction force F. Okay, so in case of the frictionless pin or in case of this rough surface, there is one force with unknown direction, or means with unknown line of action. So there is one reaction, this is one reaction with unknown line of action. So here this is F is not known, as well as this angle alpha is not known. So what we do in this case in general, we resolve this unknown force into its rectangular components. Rectangular component means one horizontal and second vertical. See, it is something like this. Say suppose this is one force, say suppose 100 Newton force, making an angle, say suppose say 20 degree. Okay, this is another force of magnitude, say 150 Newton, making an angle, say suppose 30 degree. Now when I resolve these two forces along x-axis, their line of action is same. Please note that it is directed along x-axis. Are you getting what I'm saying? So what about x component of this 100 Newton force? X component of this 100 Newton force, it will
100
be
cos 20.
correct, 100
100
into
cos
cos
20.
of 100 into cos of 20, which is directed in positive x direction. That means along x-axis. Similarly, when I resolve this 150 Newton force along x-axis, then what will be its component? 150.
150 cos 30.
Yeah, 150 into cos of 30. Okay, 150 into cos of 30. Now see, what are their lines of actions? Lines of actions are same along x-axis. Okay, so what we did, we resolve this 100 Newton force along, say, this y-axis and then x-axis. Similarly, we resolve this 150 Newton force along x-axis and along y-axis, something like this. Are you getting what I'm saying? So say suppose now, so this is one force, one unknown. Say this is one unknown, for example, say suppose one unknown, I mean the F with unknown line of action, say alpha. Now this one unknown that we are going to resolve into two components, one along x-axis and second along y-axis. So means in short, we are going to consider in short these two unknowns. One is along x-axis and second along y-axis. So means in short, in case of hinge support, there will be two unknowns. Okay, so hinge support is replaced by, or hinge or the pin support is replaced by two unknowns. What are those two unknowns? Two forces, one along x-axis and second along y-axis. Got my point as far as this hinge support is concerned? Yes or no? Any doubt in this discussion? So in the hinge support is replaced by the two reactions, one along horizontal axis and second along vertical axis. Okay, and please note that in hinge support, the hinge support won't allow any translation. Won't allow any translation means what? When I apply a force, so suppose when I apply a force F onto this particular say rod, then it will not, this point A will not move from this location to say this location, but it allows rotation. It can rotate like this when I apply force in horizontally say rightward direction. Okay, fine. Yeah, coming back to this problem, and break problem. Yeah, let me finish this problem and then we will stop. Okay, fine. So here we have, first of all, we are going to draw the free body diagram of the flywheel. Only flywheel, please note that. And here we are neglecting the weight of the flywheel. Okay. Even if you want to show, fine, you can show, and of course it is acting through its center of gravity. So suppose weight capital W is the weight of the flywheel. So what are the various external forces acting on this flywheel? Of course, now here, see, this one is hinge or a pin. Please note that. Here this is pin. That is why it is free to rotate. Flywheel is free to rotate. Please note that. This is a hinge, and that is why it is free to rotate, just like a door hinge. Door hinge, if I apply a force onto the door, it allows rotation. It opens or it closes after applying the force. But whether that hinge point moves from one location to the another location, hinge point, I'm talking about hinge point, no. So that means hinge support doesn't translate, but it allows rotation. Okay, fine. So this is what this hinge support is allowing rotation. And as there is a hinge support, so that is why we are showing the two reactions. I mean, this hinge support is replaced by two reactions, one along horizontal direction and second along vertical direction. Now you might be thinking that what are their directions, whether shall we consider leftward or rightward? Similarly, about this vertical component, whether shall we consider upward or downward? No problem. You may assume any direction whatever you want. You may assume, say, this EX may be leftward or maybe rightward. Okay, similarly for EY, you may assume, say, in upward direction or downward direction, doesn't matter. Okay, fine. Okay, what is the next force now? Now we are drawing only FBD of this particular this thing, I mean flywheel. So here we are, I mean, see, only, I mean, we have to detach. We have already we have detached this pin support by its reaction, and hence we have shown here. Yeah, hence we have shown here the two reactions. We have replaced the hinge support by the two reactions. Similarly, we are going to detach this flywheel from this flat belt also. Okay, so this in the flat belt, what is the nature of force induced? Flat belt is a flexible one, so there must be a tension. Okay, so there is a tension in this portion, right? Okay. Okay, so as far as this the flywheel is concerned, so flywheel, I mean this flat belt is leaving the flywheel at this particular location, and similarly this flat belt is leaving this flywheel at this particular location. Okay, so this flat belt is leaving the flywheel at these two locations, location 1 and okay, this is location 1 and location 2. Okay, now see here, let me erase this point. Okay, So this is your location 1 and say this is your location 2. Flywheel is rotating in which direction? Clockwise direction. Now can you tell which will be, which side will be the tension side and which side will be the slack side, whether 1 is tension side or 2 is tension side. See, it is flywheel is rotating in clockwise direction. See, the direction of rotation is very important. So which side will be stretched more, whether this one or this one, like this. See here. Can anybody answer? See here. See the arrow. I see the cursor. Whether the cursor is visible to all of you? I'm moving in clockwise direction. Yes or no? Is it visible? Yes or no? Please give me response.
Yes, sir.
Yes,
So
sir.
which side is the tension side, whether first or second? No doubt. The first one will
First.
be this thing, your tight side, T2, and this will be your T1, slack side. Got my point? And that is what is
Yes, sir.
shown here. Okay. Right, so this is T2. Of course, now T2 is your tight side. You may use any symbol, whatever you want. In some of the books, T2 is considered as a slack side, while T1 as a tight side. The symbol doesn't matter. You may use any symbol, whatever you want. But representing whether it is a tight side or slack side is very important. Okay, so T2 is your tight side, while T1 is the slack side. So this is the so knowing this particular relationship. I know cricket match is going on, so please if you want to watch, you may continue. Okay, just I will take another 2 minutes only to finish this problem.
उस नजरिए से काफी अनुभव है, एक ऐसे बल्लेबाज है जो काफी फ्लेक्सिबल है।
Okay, fine.
बल्लेबाजी करते थे 4-5 पे।
Okay, so this is your tight side and this is your slack side. Right? And knowing this particular relation, so how much is the total lap angle? This much is the total lap angle. Okay, that means 270 degree. Convert that 270 degree in radians. Okay, so this is 4.71 radians, and hence, okay, using this particular relationship, we got the relationship between T1 and T2. Okay, so very quickly, let me finish. Then we are going to draw the free body diagram of this lever. Okay, so this is the lever.
Baby, look. मैं इसी तो शायद और पावरफुल एसी हो जाता है। 60 डिग्री सेल्सियस में भी चिल करता है। पर आजकल वायरस बैक्टीरिया से प्लाज्मा प्रोटेक्टेड शील्ड है। Switch on the AC.
Okay.
क्या करें? मेरी चॉइस ही ऐसी है। Heavy duty AC. It's not just heavy duty. But a feature loaded heavy duty. आप भी सर्च करिए। समझ के पढ़ते हैं तो इनका दिल लग जाता है और पेरेंट्स से पार्टनर तक का फासला।
ठीक है, okay, fine. Better we will stop here because I think this is what I can say, more than 1 hour almost. Okay, we will continue.